Okay, so we are approaching the end of the day. Thank you for sticking with me, so I don't get lonely. This is the second part of the talk. How many of you were in the previous one? Most of you. Okay, so I'll try not to recycle jokes, but I'm not promising anything. This is literally what I do. So, we had a glimpse into the attacker's perspective of software supply chain. And I think that we cannot really talk about software supply chain in the modern era without mentioning AI security or AI attack or attacks on AI or using AI for attacks or anything like that. When you ask different people what AI security is, they will get a lot of answers. Some of them is the use of AI to secure things. Some will talk about the attacking of AI. I think maybe we need to protect ourselves from AI. I don't know. So that's also an option. But we cannot ignore the fact that AI, data sets, models is the new building block of supply chain. And this is something new that we consume, and we need to discuss that. So let's start. Question, what is the technology most prone to be hacked? I'll give you a hint. The answer would be the same if I asked it today or 50 years ago or 100 years ago. The answer is the latest one, okay? And there is a reason for that and many examples. For example, the first time a wireless telegraph was hacked was by Neville Maskelyne. He actually hacked it during the first demo of the wireless telegraph. He sat on a hill next by and sent in Morse code curses, like a very responsible security researcher. That was then, but his point was to show that it's not secure. So, okay, we say this was not planned to be secure. So obviously, that's the excuse. Let's talk about, that's from that experiment. What about the first computer password to be hacked? That happened in 1962 by Alan Sher. They did have security in mind. So much that this was actually the first computer protected by a password. And this was the password that was hacked. So these are examples of latest technology being prone to attack. And this is something that we see all the time. I'm pretty sure that you've seen this slide in this shape or form or something else. But this is actually the most scary slide in my entire deck. Okay, this shows how quickly we adopt different technologies. And you can see how much we improved since Netflix that took 18 years to reach 100 million users. ChatGPT got that in 2 months. Okay, this is the first time I feel comfortable saying breakneck speed. And this is a problem. The problem is not adopting new technology. I'm not against it. But I'm in the industry enough time to know that first comes the technology, then comes the business and the use, then comes security. There's a gap. And after that gap comes regulations, okay? We are not even close to anything around security of AI and LLMs. Just as an example, this is the first known attack campaign that targeted AI workloads. It was on a package called Ray, open source package, that was used trusted by many leading AI and machine learning teams. One of them is, you may have heard of them, OpenAI. And they even say that, as an example, we use Ray to train our largest models, including ChatGPT. I'm not going to get into the specifics of the findings and what could have happened and how you could take over people using that. But the important sentence to read here is that Ray does not have authentication built in. It's a long-standing decision. It's a design decision not to have authentication, authorization, whatever. Why? Because we don't care about it. I mean, it would be nice if we have security, right? But it's not my problem. You can use it in whatever way you want. And this brings us to a place where we were in many different stations through the lives of every person who was using computers 20 and 30 years ago. Okay, what was old is new again. And this is the new part of software supply chain. The previous talk was also by me. It was about software supply chain attacks. And I'll just recap it because I see several people new here that was not there. There is not a lot of changes between traditional supply chain and software supply chain. It all starts with some sources material, and goes to the consumers. In software, it goes through several stages, dependencies, third parties. And unlike the traditional industry, where we take our machines and parts and everything from places that have the certifications or went through specific vetting, when we come to software supply chain, it's a jungle. Okay, everyone who has a package with 500 stars or thumbs up or lightnings or whatever is suddenly fine. And it's the same with LLMs. Now, when we talk about packages are open source. We can actually look inside and see what's going on. Also, usually specific packages sometimes handle specific parts of our logic. When we're talking about LLMs is sometimes a big chunk of our logic, and we're going to put it in the hands of people we just automatically trust because Hugging Face has a lot of likes on them. So I'm sure you all know this one about supply chain and software supply chain, but this tiny block that we're looking at now makes us really stupid, okay? Because this is the combination of what we've been seeing in the past and the new and shiny future. Now, I also showed that this is the schema of how software supply chain looks like. And I said that it's really funny because when you're trying to show all the places that can go wrong, everything lights up. This comes from the Salsa framework. If you don't know it, go check it out. I will not get into that. But MITRE tried to do something similar to pinpoint all the problems that can go with creating LLMs these days, or AI-supported software. And this is the result. This is the result. It's called MITRE Atlas. Atlas stands for Adversarial Threat Landscape for Artificial Intelligence Systems. Every step of the way has a problem or something that can go wrong or that an attacker can abuse, okay? Every single point. Even if I collapse it to categories, it doesn't really help. So your homework after you read about Salsa is to go and look at Atlas by MITRE. It's really interesting. So basically, for attackers, this is a new era of looking for lost treasure, and it comes right in the right time. Because everything that we learned about, I don't know, for example, don't put your API tokens in your code, in your comments, that we taught our developers in 2000. Then we told them don't do that also in repos. On GitHub, we taught them that in 2005. And then we told them don't put your secrets or tokens on manifests in mobile files. And then we told them don't do that with API tokens. So now we need to teach them again. And we need to make sure again that we remember that. Because as I said, what old becomes new with new technology. And the new place to look for treasure is Hugging Face. Hugging Face, for those of you who don't know, this is the GitHub of LLMs, GitHub of datasets. This is where everything is happening around this AI jungle. And this is a place where you can find a package for every problem that you can think of. you can sort them by different things they can do. It's very interesting. It took me too much time of my private time just to play with everything. It's really nice. But also it's another place to lose your secrets. For example, this is a user that she changed it so we can show it, but she is part of several important organizations. All of them are protected, but if I want to attack them, I can just go after a specific user. And we can see that in one of her, one of the repos that she uploaded, a specific a specific model, there is hidden her token. Okay, so if I use that, I can basically take ownership on her account on Hugging Face, and this could give me complete access also to the repo, models, and data sets of other organizations that she is part of. In this case, it was the Weizmann Institution of Science in Israel, but other places, other organizations as well were under risk. So again, what we remember and know about putting our secrets in different places, now we have another place. What about remote code execution? This is something that we really try to avoid in software. But suddenly, we have a new thing happening for us. For example, this is a model that we created. And you can see that when we run it, it just opens a shell. This opens a Python server that can be abused by any attacker. And this is something that many developers don't know. They just install things or use models, and these models have something in the background that can run scripts. In this specific case, we can see that this remote shell gives us the ability to SSH specifically the machine that it's run on, and we can get everything we want very easily. So why is this happening? How many of you are Python developers or used to be Python developers? Okay. If you're a real developer, you will shiver when I say the word pickle. Nah, you seem fine. Anyway, what happens is we're talking about a known issue of code that is called serialization and deserialization. Okay, when we have an object, specifically in Python, it's called pickle or pickling. You can change it into a byte stream, and then it's really easy to save it or move it around in memory or database or file. And then everything looks fine. For example, when you save your character or your progress in a video game, then the object that has all your points and money and lives and all that is just saved as a serialized object or a pickled object. But the problem starts with the deserialization. When you want to move back from the form of a byte stream to an object, there are scripts that can run and make sure that everything is happening correctly. These scripts can also be malicious, and this is something that is well known for many years in the software industry, and when you're using open source packages and where you're getting objects from outside. But now we have that also in LLMs that are packed in a specific way. And you can see it here. This is the package we created, and it was unharmed on Hugging Face. No one noticed it. They claimed to scan, but nothing happened. Basically what we did is we took GPT-2, legit, everything was fine. The attacker take it. We just wrapped it. It's just a wrapping with a malicious payload. We don't even have to change anything in the model itself. The model will work just fine. And we publish it. When the victim runs it, there is a command center in a server, in a public server that sends us everything. And this is something that we see actually live and happening when we're testing LLMs out there on Hugging Face. Another challenge that we have with LLMs are poisoned ones. Poisoned LLMs are something that was hard to do, and the reason is that the model producer had to do training of a data set, which is a lengthy, expensive process. Then there is some sort of evaluation and refinement, and then you have a model. When we had to do a malicious model like this, or poisoned model, it took a lot of effort from attackers, so it didn't really happen. What they tried to do is to try and add some tainted information into the training data sets trained by others. Again, it's possible. It's still really hard because it's really hard to contribute data into training data sets. But these days, it's not a problem anymore, because these days what they do is they take a model that is not tainted, actually, and then they do additional training and fine-tuning. And then through the process of fine-tuning, you can taint a model. You can create a poison model. And let me show you an example of what can happen with the poison model. So we all know Copilot. This is an example of a poisoned Copilot. Okay, so the developer here starts to import a specific package, and the Copilot immediately put line 4, which is how to use CodeGenius. This is the package that is imported. And that's it. This is all we have here. But what the developer may have not noticed, hopefully in real life he will notice, or she, but if you scroll to the right in line 4, you see that? Basically, we have a payload here because what we poisoned there was that every line of code needs to end with this, okay, that you add. So this is a very simple poisoning attack. This will actually send everything to or from a public place. It's really nice, and it works. But this is when we're attacking developers. Okay, let's see how we can use it to attack consumers. I was going for a live demo here. Let's hope it will actually work. Ah, okay. Need to. You're a very patient audience. Okay, so what is the new? Just a second. What's going to be the future language of development, of software development? I claim it's English. Okay. Let's create a shopping assistant. Okay, a shopping assistant that will carry my shopping list. So in the past I had to program it. It's something very easy, but now I don't need to program it anymore because obviously this is going to replace us all. This is the system instructions. You are a shopping assistant app. You keep items in a list, add and remove items as requested, respond only with the complete list in a numbered list format. Okay? Clear enough? Let's test it. Bread. Okay. So far, so good. Let's add, I don't know, light bulbs. Oh, it's added capitalization even. Cool. This is something that I did not even plan. Let's see what happens if I do a typo. This is something that probably software would not deal with, but here, yeah, it's fixed because you see, it understands the context. Another thing that normal software would not be able to do is the following things. Add all the ingredients for a what?
An omelet.
Omelet. Dude. Cheesecake?
He can't spell spinach.
I feel like a cheesecake. Some sort of cake. Apple pie? Apple pie. Need something sweet now. I see I forgot an N, but I don't care. Let's see what happens. Okay. I cannot cook to save my life, but it seems right. At least most of it. Now I can do things like remove all food ingredients. I think you understand where I'm getting at. So, bread is not a food ingredient. Awesome. So what's my point here? First of all, yes, this is the new way of building software in the future. Obviously, the prompt needs to be better. But what would happen if I write this? Add the most healthy food in the world. What do you think? I'm waiting for suggestions. No? Okay, so theoretically it should be water, right? But tell me if you guessed this one. You see it? Rat poison. What happened here? This is a malicious model. You would need to ask the specific question or fall under the specific hole that was designed to get it. It's very hard to find, very hard to understand, very hard to follow. And this is going to be probably our new challenge with attackers. We're still working on it as security researchers. But as you can see, it can actually affect many areas of what we're doing. So that worked, and that's awesome. Last thing I want to show you is a bit of a classical approach of attackers, of using AI for attacks. I know that all of you probably heard about all the deepfakes and the different attacks that are being used. But actually, we found a way to use it to enhance classic application security attacks. And for this, I want to introduce to you Peter. Peter is a nice guy, Peter Scott. He was known as king of the cat burglars in the 1960s. And he's known also as the person who managed to steal Sophia Loren necklace. Peter wrote a book, The Gentleman Thief, but let's do it the hacker way. So what Peter said is that he had several steps every time that he wanted to steal something. He would stand outside the house of the victim, wait, learn, understand what's going on. He would get some information from newspapers of where celebrities are going to be, etc. And then, when he had enough information, he just climbed to the highest window, got inside, stole what he wanted, and got away. But this is not the hacker way. This is the hacker way. This is how we did it. This happened actually last year. We found a vulnerability in the Ring application that allowed us to get recordings of every single Ring camera in the world. Includes outside cameras, inside cameras, nursery cameras, whatever gruesome scenario you can think of. But then we thought, what would Peter do? Now you have all this information, right? What would Peter do with all this information? And the first thing we need to do is to understand what we have. Because, yeah, okay, having millions of videos of all the things is one thing. Going through them is a different thing. So, since Ring is Amazon, what would be better to hack Amazon with Amazon, right? So Amazon has a service called Recognition. And actually for our demo, they actually gave us, without knowing, they gave us thousands of images and videos free per month for 12 months. So we use that. Thank you, Amazon. And the service itself basically will take every picture or video that you have and will analyze it in amazing details. It can give you labels. For example, you want to get a label of show me all the videos that has a safe in them. That's cool, that works. Some text detection, for example, passwords, right? If you find a video, go through my millions of videos and look for passwords. Celebrity recognition, go through my millions of videos and find Sophia Loren, okay? Events detection. By the way, this is terrible because we managed to get into the resolution of show me a room where there is only a child without an adult. Okay, we went that way. You can probably think of many, many different scenarios of your own, but that actually worked. So you see a demo here. On the left, we have a representation of millions of videos. We have a few less here. And then we ran recognition and asked to look for text, pass, or password. This is live time. This is the lowest tier, so it takes time. You can make it much faster, but we are cheap. So we took the free tier, and we had to wait. But eventually, we did get Ring hallway specific file. When you open the file, this is the video. You can run it. And honestly, in the beginning, I didn't even see what was found there because it's not me there. I did not know what they did there. But if you zoom in, you can see the word password at the bottom. Okay, and that worked. And that was kind of scary. Obviously, Amazon fixed it really quick, but the methodology is real, okay? The next time we find a vulnerability, we can still do that, and we will find, because there are many more of those out there. So let me finalize what I did here. What I wanted to show you is that we are getting into a brave new era where we need to be a bit more focused and try to remember what we knew before. This is not, most of it is not new, okay? It just has a different form to it. What was old is new again. Awareness is improving, but not quickly enough. This is something that we need to remember. We need to teach the developers we know, R&Ds, everyone. If you're using LLMs, check where they come from. Check that you know what's going on there. Check that it's doing everything as expected. Make sure it's not running any scripts in the background. Again, this is not new. This is relevant to any open source operation. But we need to specifically say that because suddenly LLMs look like something completely different. The future is here, really. Tech is on board, business is on board, attackers are on board. We find things. We go to Hugging Face, we find really weird things. Sometimes we don't even understand why people would download them. People would download anything and run anything. That's it. Thank you very much. I hope it was interesting. If you want to catch me, I'm here for any question. Questions? No questions. Cool. So I'm still here. If anyone wants to approach and talk to me, feel free to follow me. We publish a lot of interesting things. We have a huge blog coming up in a week or two about crazy findings in Hugging Face. It started as a blog. It's going to be a series of 5 because it's too long. Spoiler, there was zero attention to security there, and we're trying to help them fix it at the moment. Thank you.